from UC Pertahanan, and my presentation today will be on the satellite tracking system, which was developed a few years ago and been currently also being used by aircraft and also being still under further development. Okay, what motivated me to look into this tracker was incident happened in Aerostar where the pilot crashed after low-level aerobatic, and then from there onward, I came up with the idea of to have a single tracker that can be carried on board of aircraft and be able to track aircraft while the aircraft is flying. And after we've done that development, when I was in UPM, we flew on the Sidus SR20. Our students have a quite good time getting data and be able to retrieve data for analysis. Then later on, the incident on MH370, you can see, have created a bit of interest in this tracking system. So what happens is that people are still haggling regarding having a tracker being installed in aircraft because of the cost. But actually, cost that our system provide is much cheaper, right? So the tracker that was developed has so many applications. It's a matter of basic unit that contain initial measurement unit plus gyros, accelerometers, magnetometer. GPS now already covered by GNSS, so we give you a very wide coverage and a better detectability of the system. And we can use it for aerospace as well, for territorial, and also for early warning. We're looking at using for hill slope, which are currently being developed in UPNN. So there are many benefits here. I would like to. I couldn't do everything here because time constraint. But you can read later on in the paper that I produced. Here you can see that this thing has been tested on helicopters, on wind in ground effect craft, and also on fixed wing airplane. Data is abundant in the sense that the data is telemetry, right, from the source through Iridium satellite and come to your server through internet protocol gateways. And also some data can be gone through GPRS, which give you mass, the massive amount of data that can be analyzed at your laptop or iPad because it's web-based. So for this, we don't need a lot of infrastructure for telemetry system. This is an example of wind in ground effect at Malacca. That was tested using our equipment. And one of the reasons why the pilot of this aircraft was very scared of flying in the sea unless they got something that can detect them for search and rescue purpose. It's not very familiar. So we fitted it and they're able to flight test in Malacca. And this is the track. You can see a lot of data there. Every piece here, you can it will give you information about the aircraft attitudes, speed, direction, and also all the accelerometer data. The red parts are all those data that have been transferred using GPS. Iridium. I mean using satellite communication. The rest all data transferred through GPRS. So in this case, your usage of satellite communication is very much minimized, and you'll be able to have a lot of data in real time. This is an example that we tested at Malacca. But I don't think I want to go to that line about it, but just a short video to show you this is a test that we did on the, I think was it Cessna. Okay, this is a big, it's a small box, but now it's already much smaller. Yeah, and this is a Hero flying aircraft. They look like me, and you can see that. You're not laughing, huh? You are not humorous at all. Okay, you can see that the aircraft is transmitting data to the various internet through the various satellites, yeah, network, and the data is going back to the Earth, right? To our internet gateway, and then to the server. And all these data are secure. You can see that these are data taken, and this is the type of thing that you can see in real time. Okay, this is how the architecture of the system. It can be aircraft, ship, or land vehicle fitted with our tracker, and it can telemetry data through Iridium or through GPRS or GSM. Go to Starfish server, and the follower go to your laptop. In other words, as long as you are connected through a web base, you'll be able to get information about the aircraft, or your own aircraft, or your own wife, or girlfriend, or boyfriend. Sorry, you're not laughing still. Okay, so basically what I say, you are always connected. This is what we call it the Internet over Things. Okay, I wouldn't want to go to detail. If you want, I can give you a copy of this. But what I want to show you, this is a module that we developed, and this is using what call it Iridium transceiver, and at the back is a GPRS module. Okay, these are information that you can get, and we call it fleet management. Once you already subscribe to it, you'll be able to get data and be able to analyze it. Okay, this you can see that we are using Google as an environment. So if you wish to use other form of map, big map, or this is possible. At the moment you're using Google, which costs us nothing. Yeah? Okay, if you can see the data that you have, you can archive it. That means you can download as a forensic data. In case of any accident, you can really replay it, or you can analyze what really happened to the aircraft. But the data we are taking only basically from the sensor, not from the aircraft, because we don't want to disturb the aircraft system. Otherwise, there are a lot of supplementary, what I call it, type certification process that can be very expensive. So we only concentrate on board standalone sensor. Okay, for example, this is I think it was the 5th of July, taken on a helicopter in Aerotech, yeah? And you can see that data there for 1 hour flight, right? And if you were to look at the here, you can see that all the red parts are from Iridium. The rest is all from GPRS. Because the aircraft is a bit low, flying low, about 1,200 feet. And Gunung Kedapik is about 3,000 or 5,000 feet, fitted with the Celcom. So the Iridium only fill up the spaces that is really blind from GPRS. So the sensor will program, or the unit will program in such a way it tries to optimize usage of satellite communication. This is in the form of just now it was using the satellite image. Now it's a map. Yeah? Sorry. Okay, these are example of the data in terms of time, latitude, longitude, speed, altimeter, direction, and all this. If you were to look, you can get what call it, average for say over a period of 1 minute. And this is shown here. You can see that the time, right? With the time, this is the heading, speed, and altitude. So this data have been converted to the data we have is more in the meter in MKS, and here is in terms of imperial, and from that you can see that they are same. Yeah. Okay. You can even take the data itself and break it down into, for example, speed and altitude profile. And you look at the helicopter, how the way they fly, because it's a training helicopter. So the pilot been doing a lot of maneuvers. At the same time, they're doing a lot of call it auto rotation, right? Where you drop from a high height until you reach the ground and flare, and then climb again. Because it's part of practice for their routine practice. Every flight they do that. That's why they become very conversion in case of emergency or in case there's an engine failure. So that means the data can be used for analysis. Then the data that you can get from, okay, if you were to superimpose the data, you can see the full flight profile. So even an examiner or the pilot itself be able to correct their mistake in case they have a sort of data enough for them to analyze their mistake. Here, there are data from sensors, from gyros and accelerometer that give you a lot of your information. These are all 3 axes. I think this what happened is not playing. It's supposed to be. I don't know. Yeah, it's supposed to be live that you can see, but it's not responding. Right. So finally, this is what we achieved after through about 3 or 4 years of development. Presently, the Air Force have shown interest in this because they found that the data they have is very useful, and some few crashes which they cannot determine because they don't have the good information about the flight profiles. If this have been fitted on MHS 370, I'm sure we're able to track right to the point of impact. And if you compare with the present system, which is about 15 minutes interval of transmission, this is transmitted at every 1 second. So imagine you're at a very high speed, you have a smaller area of search to detect your victims. Right, with that, that's all I have for my presentation. If you have any question, I'll be happy to answer your question.
Thank you, Associate Professor Tarmizi Ahmad, for your presentation. I'd like to invite to the floor for any question and answers. For any questions.
I might have one question.
Yeah, please.
So, in numerical values, I would like to know what is the accuracy of this system and why you always referring to GPS satellite. Because there is other navigation system currently working like GLONASS, Galileo, and others. So and it looks like the system is working perfectly without any limitations. So I'd like to know what's the accuracy of the system and what is the limitation, please.
Okay. Actually, the current system using GNSS. It's not GPS alone, because GPS sometimes you lose some signal, especially in our very clouded atmosphere. So we really using GNSS and we have very reliable data. So your accuracy, we're talking about 200 millimeter, because they're about more than 30 or 40 satellites. Compared with GPS, you're talking about 12 satellites, or maybe sometimes drop to 4 or 5. So it's about.
How many satellites?
Well, another thing I have to warn you, we cannot want to have very high accurate, because it's not meant to be a homing or guidance system, right? But with 200 mm is very accurate. If you want to improve, I can use RTK processor with differential GPS. But now we don't need, because with the present GNS is really accurate and it's cheaper.
And the limitation, please, the limitation of the current system.
Limitation, only thing when it comes to speed. Yeah? Speed in terms of if you go to Mark 3, Mark 4, which we haven't looked at, then we have to do some data fusion between the IMU and our GNSS. But then alone, it depends on the sensor. If you go for low cost, then it doesn't help at all. So this is meant for not really expensive that equipment. Yes, sir. The only thing is that all those chips that we do is programmed ourselves. We are not using any other third-party software. Even the operating system also is done by my programmer. Yeah. So because that, our usage of the power supply is very minimal. We don't need to have any cooling system requirement. And we only have about 12 volts battery with capacity about 8 hours. And it's a rechargeable deep cycle battery. So it's I can say it's a very, very cost effective compared with what's presently available in terms of operation as well as acquisition as well. Now we also fitted with the Wi-Fi, so that should do any maintenance, we don't need to open the box, we just change program through your laptop. So a lot of development is still ongoing. Very soon we want to integrate with the camera. So instead of what you see in the earth, you see in real time. But that also, I can say we have to be careful because the processing is a lot. And to give you real time with the GPRS may not possible, but I can give you into of a snapshot. Okay, any other question, boss? Yes, sir.
I can see, mashallah, it's a very wide program. I want to ask how many persons work on this project? And you said for 4 years?
4 years,
Yes.
because we don't have no fund, no money. It's our own interest. So to test it, so we don't have money to test on aeroplane. So every time we have availability, somebody want to volunteer, then that's the time we manage to test it. So the working people are only about 4 or 5 of us. Not many, because but the main thing is that we got the new chips nowadays. So this is still make it more exciting. So there's no end to this development. Yeah, any other question? Right, thank you very much for listening. And in case of you need any of my equipment, please do come around. You have any husband to track, wife to track, we can track with a smaller, more costly, less costly equipment. Thank you very much.
Thank you very much. Thank you, the presenter. So for our next presenter, okay, I have asked for the last presenter actually, due to personal reason, like to invite Wing in Ground Effect Craft, a case